Más tarde, apúrate si quieres una buena calificación.
Voy lo más rápido que puedo.
¿Has pensado en correr? Es saludable y eficiente.
Seguro que no hay más trabajos disponibles. Yo estudié para ser profesora y estoy haciendo mercados.
Y además puedes quedarte con los puntos de fidelización. Eres una monje afortunada. Tienes que confiar en la aplicación. ¿Te sientes inspirada? Gracias. Chao.
¿Quién soy yo? No, eso no es lo que quiero decir. ¿Para dónde voy? No. Puedo volver a empezar. Olvídalo.
Estoy presente ahora. Y me amo. Estoy libre de mi ira. Estoy libre de mi tristeza. El amor es mi experiencia.
Habla español. Ayer. Hola, me llamo María.
Bueno. Hola otra vez. Ay, no, cállate. ¿Qué está pasando?
Buen día, Emilio. ¿Qué puedo hacer por usted?
¿Qué está pasando? Mis puntos están bien.
No se preocupe. Sus puntos están seguros conmigo. ¿Le puedo ayudar en algo más, Emilio?
Yo no soy Emilio. Yo soy Juliana Restrepo.
Por favor, espere.
Hola, Juliana Restrepo. Me alegra verte. ¿Qué puedo hacer por ti?
Mis puntos están bien. ¿Qué está pasando?
Tranquila, todo está bien. Parece que alguien está intentando vulnerar su cuenta. Por favor, espere mientras reinicio su dispositivo. Hola, Juliana. Me alegra verte. Hoy te ves hermosa. ¿Estás estrenando zapatos?
Ya lo arreglaron. Tengo que seguir trabajando.
Estoy trabajando en eso, pero necesito verificar tu información biométrica. Por favor, sigue la línea azul hasta el centro de servicio más cercano para confirmar tu identidad.
Sí, pero mis puntos están bien.
Todo está bien. Chao.
¿Qué? ¿Qué ¿Qué? ¿Qué está pasando? No, mis puntos. ¿Qué hago? ¿Qué es eso?
So I'm going to be talking about using AI to help cities make better decisions. I'll present myself soon. So imagine you're a city manager or city mayor going into a pub and listening to the citizens of the city. What will she hear the people talk about? How would that influence her work when she gets to work the next day? So usually city mayors and city managers can't always tell the right decision. When you're a business company, it's really easy. It comes down to money. You make money, you know that you've succeeded. But in cities, you don't have the information. So sometimes you make decisions and you just don't know if they're the right ones or not. You're lacking data and technology to do that. So many decisions are built on guesses. This is what me and my team are doing the last few years. We are building software and data science products that are helping cities make better decisions. I'm Anat Rapoport. I'm the VP R&D of ZenCity, a startup in the GovTech and smart cities area. So why AI? When you're a city and you want to keep track of what the people are doing, you can easily keep track of one Facebook page, 10 Facebook pages, maybe even more Twitter pages. But when you have a huge amount of pages and a huge amount of data that you want to keep track on, you just can't do it. And here is how the machine can. So in ZenCity, what we are doing is we are taking a huge amount of data, analyzing it, and helping the city come to decisions. So, for example, when a city wants to have a new project, they want to build a new park. How do they know how the people will use it? How do they know where old people feel lonely and want to have places to meet? How do they know where benches are missing and are needed in parks or in the streets? How do they know where women walk alone at night and feel unsafe? They just don't know. So, decisions are not backed up with data. Does anybody know how in the US decisions are being taken in City Hall? Do you know this process? Does anybody know it? So when a city needs to take a decision to start a project, they invite people to City Hall, and then people are voting, but it's a small minority of people coming to this meeting. Not everybody knows about this meeting, not everybody comes to this meeting. So the way this decision is taken is both by small amount of people, it's undemocratic, and it's not based on data. So without data, you're just another person with an opinion. There are a lot of transportation projects that start as a huge success and fail. So there are so many reasons for why transportation projects fail. For example, there are not enough routes in the city. There are not enough stations. And one type of failure is something that ZenCity helped one city in Israel, is that the project was ongoing in the city, and there were a lot of traffic jams, and the city was a little bit ruined by the project. And people did not understand what's going on, why all this work is done, what's going on in the city. And the city people didn't even know about it. The city mayor didn't even know about it. But with ZenCity, it discovered that the messaging is not going well. And what they did is they changed the conversation and the messaging, and the project was again wanted, and it's not a success yet because it's not done, but at least the people of the city are now happy about it. So they shifted the messaging, knowing what ZenCity, getting the ZenCity information. Another city that we worked with wanted to build a downtown, so there was a small minority of people objecting to the project. But it was a small minority. The city didn't know what most of the people wanted. So ZenCity created a survey, published it to the people of the city, and then we discovered that the small minority was wrong, and 80% of the people wanted the new downtown. Another thing that we did is we published an open question asking the people, what do they want in the new downtown? Once we had the answers, we ran AI algorithms on them, and we discovered clusters of wishes and stuff that people wanted, and reported back to the city. Now the city is starting to build the downtown, and we are hoping it will be a great success. So this is how ZenCity's dashboard looks like. As I said before, we are collecting data mostly for social media, from Facebook and Twitter, and we are getting comments and posts. And what we're doing is classifying them into categories and sentiment. So categories, you can see, we have 80 city categories like police, public works, parks, festivals, education. Whatever city category you can think about, we have one. So for each data item, we decide to which category it goes to, and then we also decide which sentiment it holds, and then we can tell the city which categories are not in such a good shape, and people are complaining about, and what are the topics they are complaining about. So I started from the pub. So ZenCity is kind of a virtual pub, meaning the mayor can go into the virtual pub and understand what people are talking about and how they feel about it. So all of you, or most of you, are data scientists and researchers, right? Can you raise your hand? Who is data scientists or researchers? Okay, most of you. So this is like the more technical stuff. We have an algorithm for categorization, which is a neural network LSTM algorithm. Our results were not so good. They were like 73% right, but we had a confidence score for the data. So this helped us decide. We also have manual annotators going over the data and seeing if the algorithm was right, but they cannot go over all the data. This is exactly why we have models in data science. So now, using the confidence, we build queues that allowed us to only tag the stuff that is more tending to errors. So before we implemented both the new algorithm for categorization and the queues, manual work was done all over, but we were much smaller then, and we had much less data. Since then, we grew like 3 times, and the data grew more than 3 times, because now we have bigger customers like Chicago and Houston and Ottawa in Canada. So we cannot tag everything manually, as you can understand. So, just a second. So what we're now able to do is tag much less. Sorry. What we're now able to do is tag much less, and with a high confidence that what we are tagging really needs the manual tagging. So this was good for us. Another thing we implemented in categories was languages. What's important about that is that it was based on translation. So we are supporting 5 languages, English, Hebrew, Spanish, Serbian, and French. So English is the basic model, and Hebrew is the basic model, but three of the other models, the Serbian, French, and the Spanish, are based on translation. It means that an item coming from these languages is translated to English through Google APIs. I'm not publishing them. I have no connection to Google at the moment. But we are translating them and sending them to a model which is based on the English model. So in the English model, we are around 73%, and in the other models, we are around 70%, which is good enough for very low effort done in this area. Two similar problems is the steer and the mockade. One is for the San Francisco city, and one is for the city of Ramat Gan in Israel. In both cases, they have citizen requests coming to like a call center, the 311 hotline. It's called differently in every location. And someone is answering them and decides to which department this request is going to. So requests can be stuff like trees blocking the street or a broken lamp in the street. So what we're doing is helping the representative of the city to send it to the right department. If requests are not sent to the right department, it takes a lot of time till they get to the right department. And what happens then is that people are not getting service quickly enough. So we are helping the city give better service to the citizens. So city-oriented sentiment. Here we did machine learning SVM algorithm to decide if the person writing the item is thinking positively or negatively or neutrally on what they're writing. So we have 2 different models, one for posts and one for comments. If you think about it, posts and comments are not the same type of data. Usually when people write posts, they think about the post, they really put time into it, most of them, not all of them. But when people write comments, it can be people cursing or people saying, I agree, or I hate it. So comments are a little bit harder to model. So we have 2 different algorithms, and unlike category, they are working better. Like posts are doing 90%, and comments are 87%, so this is good. But anyway, we are still improving them. Just a second. What we did in this data, sentiment is a very subjective data, so we had to do majority vote. What does that mean? We didn't let only one person decide if something is, what is the sentiment of the item, because even I tagged myself data in order to understand it, and I saw that if it wasn't the same day, I tagged stuff not exactly the same. So it depends on your mood. So when we gave the data to 5 annotators, each data item, once we had a majority vote, we used it for the model to learn. But if we didn't have majority vote, we didn't learn these items. We also implemented active learning. This is only software. This is not data science. Active learning is a process, rising up in the morning, taking data from the sentiment problem, sending them to the manual queues, let's say 100 items a day. And then when the taggers are done with this data, another process awakes and finds out if there is a majority vote. If there is a majority vote, then we add them to the model, meaning we are learning actively in production. So we have an automatic process creating another model, comparing it to the current model in production, and deciding whether to switch between them. So topic clustering. So I showed you before the dashboard of ZenCity. So you can see that we are inside the specific dates, like the last 30 days. And we have a topic, public transportation. But still in a big city, you can enter this data and find like 3,000 Facebook posts and Twitter tweets. So that doesn't allow you to understand what's going on in your area if you're like head of public transportation in some big city. So what we did is we used a colocation algorithm, if anybody knows that. And what it does is it takes words like, for example, A and B, and if they appear a lot together, but they also appear a lot separately, then this is not interesting because they just appear a lot. But if they appear a lot together, but they don't appear a lot separately, it means that it's something interesting that goes together in our data, and so we added it to the lower part, which is marked in purple. So anomaly detection. Usually data has trends and seasonality, but sometimes there are anomalies. So when we recognize some change in the trend or seasonality, I mean that maybe once a day there are peaks in some categories, or once a week there are peaks because it's like the weekend. But this is like a pattern. But once data is out of the pattern, then we recognize that something happened and we tell it to the city. Usually it's stuff that interests them. In this case, in the city of Normal in the US, Amazon was opening a car factory, so it was a big issue in the city. Geolocation. So here we are using an algorithm called NER, Name Entity Recognition. Items from Facebook and Twitter, sometimes they come to us when someone checks in, so we know the exact coordinates where they are writing this post from. But usually we don't get this data. I just have to say all the data is anonymized, so there is no issue of privacy. We don't even get the names of the people. But then we can recognize entities in the data. For example, I can post something that, hi, I'm in the Spanish stairs in Rome. So the algorithm recognizes that I wrote Spanish stairs and it's a specific location, and then the item can have coordinates. It interests the city because they want to know exactly where people are talking about, in which neighborhoods people are talking about public safety, in which neighborhoods people are talking about transportation, and to understand the specific problem of each neighborhood. So another way ZenCity helped, this is not data science anymore, it's based on data science, but I'm not explaining an algorithm, is that Aurora, Illinois had a terrible shooting in February this year. A gunman came to his workplace and shot 5 people, and then the police came to the gunman, and 6 policemen were injured. And then through ZenCity, the city of Aurora found out that people are starting to collect money for the policemen, the injured policemen. And this was not something the city wanted. They felt they could take care of the policemen themselves. So through messaging and communication, they shifted the efforts to help the victims of the shooting. So now they were both able to collect money for the victims, which was really well and good for the families, and also not allow something that they didn't want happening in the city. So to conclude, as ZenCity, when we go to cities, we tell them that without data, you're risking your money, your reputation, and the connection to the citizens. But with data, your decisions are democratic, smart, and successful. So we ask the cities to listen to the citizens, understand their needs. They have all the data you need. Thank you.